Hello, geometry. So this video, I'm going to be going through some tips, I guess. I'm not going to actually do the whole problem. You have an answer key provided. So if you want to check your answer, go to the answer key. If you want to see how to get started, that's what this lesson's for. So I'm just going to get started, but for each one, I'm going to try to tell you which lesson it kind of comes from. So this one's lesson 3, the tangent lines. What you should know from that is that the tangent line and the radius form a right angle. So that's a 90-degree angle. So if I can do 90 plus x plus that middle angle here, then I can add that up to 180 because it's a triangle, right? I'm going to go ahead and erase some of that stuff. We're looking for that circled angle. But what I'm going to use is the fact that these radii are the same. So those are equal, which means that this angle right here is also 60. And from that, you should be able to find that angle. And then when you find the circled angle, you can get x. Okay. Number 2 is mainly lesson 5. Okay. That is an inscribed angle. If I can find this intercepted arc, I should be good to go. That shouldn't be too bad because I've got a diameter here. 180 minus the given arc, and you should get that. And then you divide by 2 to get your angle. Number 3 is also lesson 3. It looks like that's a tangent line, and it says assume that any line that appears tangent is tangent. That's a right angle. From what I just drew to that tangent line is a right angle. And I can, since I know that the radius is x, I can put x right there. And now I can do Pythagorean theorem. I do x squared plus 12 squared equals the whole hypotenuse, which is x plus 8 squared. You're going to have to FOIL that. And you should get, when you FOIL, x squared plus 16x plus 64. The other side, you're going to get x squared plus 144. And I'll let you solve it from there. Good things do happen when you get your x squareds together. So you can get x. Number 4 comes from lesson number 4. I've got a line that goes to the center that is perpendicular to the chord, shown by that right angle. What that means is it cuts the chord in half. So if it cuts the chord in half, I'm going to call these both y. I can do Pythagorean theorem to find y. So 4 squared plus y squared equals 6 squared. You're going to get y, and then when you get y, you double it. So 2 times y to get your x. All right. Number 5 is lesson 6, because those are 2 lines intersecting in the middle, but not on the center. But they are intersecting inside the circle, which means the distance from that intersection, that red dot, to here and here. So those 2 numbers multiply together. So 15 times 4 is equal to, change colors here, 5 times x. You should be able to solve that from there. Next one is lesson 5. I know a lot of you hate this one. You can do this a couple different ways. Some of you have learned the theorem that I've shown you. These 2 angles add up to 180, always. These 2 angles add up to 180, always. When I say always, I mean when you have a quadrilateral, a 4-sided figure inside a circle like this. Okay, it doesn't always happen this way, but with a quadrilateral, it does. That should be able to get you C and D. Once you have C and D, you can use the idea of an inscribed angle, double each of those angles to find the intercepted arcs. So I'll get you started here. The 100, when the intercepted arc for that is that blue arc there. If I double that, that means that's 200. Well, a portion of it is 99, right? That's what this is. So it's 99 from there to there, right? What A is the remaining part. So 200 minus 99. You're going to piece things together to find B. I'll stop there for that one. Number 7 is lesson 6 as well. We've got two lines intersecting, but the intersection is outside the circle. And we're looking at angles here. So the angle is equal to half of the intercepted arcs subtracted. You gotta make sure if they're intersecting outside, you subtract the angles. And it's outside arc minus the inside arc. I'll let you simplify that further. Okay. Number 8 is lesson 3. Because these are all dealing with tangent lines. This is the party hat theorem. All I'm looking for on this one, though, is x. Well, I know that these distances are the same, so 3.5 is here. And I know that these distances are the same. So this is 2, and you can add real quick to get x. I just basically did that one for you. All right, number 9 is lesson 6. The intersection is outside, and we're dealing with segment lengths. So from the point to the circle, that's 11, times from the point, and I'm going to change colors here, to the circle, which is all the way across. So that's 11 plus 20 equals, and I'll do the first one again is 13 times 13 plus C. I'll let you solve that. It's not going to be a pretty number. That's why it says round to the nearest 10th. Okay. Number 10 is also lesson 6. We've got an angle on the outside. So angle is equal to half of the intercepted arc. So outside arc is unknown right now, but I should be able to find that because it's 120 from here to here. So what's left? 360 minus 120. So 240 minus 120. Okay. Number 11 is lesson 5. These are 2 inscribed angles. They look weird, but the vertex is on the circle, meaning they are half of the intercepted arc. Well, 115 is an angle there. So it's saying that angle from here to here is 115, which means the arc, the blue arc, is double that. So 230. F is the remaining arc to make the circle, so 360 minus 230. And then E, the intercepted arc for E is F. So you take F and divide by 2 to get E. Okay. Number 12 is lesson 6. Okay, you got kind of lesson 6 twice here. We're looking at segment lengths. So you're looking at the one side of the notes that's dealing with segment lengths. So that would be the back side. Okay, on lesson 6. You're going to have to use this line over here because it's got the two known. So 4 is the distance from the point to the circle, and then 4 plus 16. So that's the whole thing. I guess I'll just start with x. Equals, well, x is a tangent line. So I need to count that twice. So it's x squared. So I'm going to have x squared equals 4 times 20, which is 80. And you should go from there. Simplest radical form is what I want. Okay. To find y, I'm also going to use 4 times 4 plus 16. But I'm now going to look at the other side, which is 8 times 8 plus y. This one shouldn't have any radicals, but you can solve that equation for y. 13 is lesson 4. I've got 2 chords that are equidistant from the center. I know that because they're both 18 units away from the center. That means the chords are congruent. The chord on the left is not 25, it's 50, which means x should be pretty easy from there. Okay. 14 is also, or is back to lesson 6. It's kind of a confusing one, I know. X is an angle inside the circle, but it's not on the center. So it's going to be the intersection, or the half of the sum of the intercepted arcs. Well, if I follow that angle, to where it hits the circle, the first intercepted arc is 180 because it makes a diameter. The other one is unknown. I don't have that one. It's this arc here. But I can get it if I do 180 minus 70 minus 60. And that'll give me what I need there, which will give me what I need there. And I should be able to solve it from there. The Y value is associated. You know what? I'm going to go ahead and delete everything here. The Y is almost a completely different problem. It goes with this angle out here. So the angle is equal to half of the arcs subtracted. Well, the outside arc here is also a semicircle. So it's 180 is the outside arc minus the inside arc, which is Y, which is a problem if I don't know the angle, but I do know the angle. So I can put 53 right here. We've done a few of these. You should be able to solve that. Okay. Number 15 is less than 6 as well. We're dealing with segment lengths. We went from angles to segment lengths. Things change. We'll do the X first. So that's going to be 11 squared because it's a tangent line. Oops. Equals, the first segment is 7. The second segment's a little tricky. It's 7 plus X plus 5. I know the formula only has 2 numbers in there, but the distance from here to here is adding those 3 numbers up. Okay. And then once you get X, you should be able to get Y because it's 5 times X equals 9 times Y. So you're going to take your answer to the blue equation, plug it in, and get the answer to the red equation. And that equation comes from the fact that the intersection is inside the circle, but not on the center. All right. 16 and 17 are both from lesson 5. They're dealing with inscribed angles here. So measure arc CE. So you're looking for this right here. It's double the inscribed angle. I just connected it there. Angle A or CBE is what you're looking for. I know that one. I just double that angle to get X. Angle A is an angle. The intercepted arc is 80. So switch to blue here. Angle ABE. It's getting a little messy. ABE is this angle. So there's a couple ways of doing that. If I could find arc AE, I could divide that by 2 and get the answer. Or I could find this angle and add it to 25 to get that angle. And then arc DE. So if I'm looking at that, I see that. I don't see. Oh, there it is. Okay. Arc DE shouldn't be too bad because I see that BE is a semicircle made by a diameter, right? So 180 minus 80. Don't overlook the easy stuff. I almost did. 17 is also lesson 5, dealing with inscribed angles. Arc AE, this one was actually on your notes. I see the inscribed angle of 51. If I follow it, I get to B. If I follow it, I get to E. So 51 doubled. This is 102. And then AE is what's left to get to 102 when I know AB is 72. BC is what's left to get to 180, right? So 102 plus BC equals 180. Angle BCD is this angle here. So that's half of this arc. So if I can find that arc, I can divide by 2 and get that angle. And then angle B, I'll go ahead and clear all this. Angle B is an inscribed angle that goes from A all the way around to C. So if I know all those arcs, I can add them up and then divide by 2. 18 is a lesson 6 problem. Okay, I'm looking for the measure of the arc visible to the probe. Well, the probe is here, so the visible arc is here. Well, if that's X, what's the non-visible arc? It's hard to see there. This one. Well, it should be 360 minus that arc. Well, I don't know that arc. I'm going to write it as 360 minus X. Right. So the angle is 20 is equal to half. Don't forget the half. Outside arc is 360 minus X minus the inside arc, which is X. And you should be able to solve that for X. All right. 19 says find the area of the circle below. Area is pi r squared. So if I can find the radius, I'm almost done. The radius is here, but I have to figure out the diameter first, right? So we'll back up here a second. I'm just going to call the diameter X. I got to remember to divide X by 2 to get the radius. I got to remember to do that. Now I'm going to use my lesson 6 material to figure out X. So 25 is a tangent line. I'm going to square that. Equals 15 times 15 plus X. So 625 equals 225 plus 15x. Subtract, I get 400 equals 15x. Divide by 15. It's not a good number. 400 divided by 15 is 26.6 repeating. That's the diameter. So 26.6 repeating divided by 2 gives me my radius. So 13.3 repeating. So the radius is 13.3 repeating. Now I just got to square that and multiply it by pi. It says give your answer to the nearest tenth. Don't forget to divide by pi, or sorry, multiply by pi. So pi, I'm up here in number 18 right now. 13.3 squared. Repeating. So what I'm doing in my calculator, I'm just leaving it as 13.333333333. I'm just going to hit squared, and then I'm going to take that and times it by pi. When I do that, I'm just going to go and finish this one out for you. 558.5 is what I get for that one. All right, a few more, 3 more. All of them are either lesson 5 or lesson 6. I'm just going to tell you they're either lesson 5 or lesson 6 or a combo of those. Number 20, you've seen kind of like one similar to that. Where was that? Number 12. I know that y squared, these are both tangent lines. So y is a tangent line and 10 is a tangent line. Technically, it's actually the party hat theorem. So I could very easily say y equals 10 because 2 tangent lines are going to be the same if the circles are congruent, which we are saying that they are. Okay, so what the other way you could do it is you could say y squared equals 10 squared. So y squared equals 100, and then you get y equals 10. I'm going to use the 10, either one of them. 10 squared equals 6 times the full length from the point to the circle is 6 plus x. And you just solve that equation. All right. Number 22. I see A is an inscribed angle. It's half of the intercepted arc, so A is 50. B is an inscribed angle. It's half of the intercepted arc, so it's 55. Now, C is the hard part. Well, it's not really that hard, but it's a little bit harder than what those were. There's a couple ways of getting it. I could figure out that angle by doing 180 minus 50 minus 55. And then whatever I get is that angle. And then C plus that angle equals 180. So I can figure out C that way. Or I could see that that angle is inside the circle, and therefore it is half, or C equals half, of the sum of the intercepted arcs. It's another way of doing it. Either way you do it will give you the same answer as long as you do it correctly. Last one is, again, lessons 5, 6. There might even be some 3 in there. A is an inscribed angle. Its intercepted arc is E. So if I can get E, I can get A. B is an inscribed angle. Its intercepted arc is the 120. So B is 60. C is an inscribed angle. It's half of D. So if I can get D, then I can get C. Okay. Let's see where we're going to go from here. So B is 60. Ignore the announcement. I see the diameter. Those are huge. That gives me E. 180 minus 120 is 60. So E is 60. In order to have those approved, meaning A is half of that, so A is 30. And now I have, this is 56. This is 60. This is 120. D is what's left to make 360. Those are all the arcs. And then whatever you get there, you divide it by 2. I'll let you actually do that math. But hopefully that helped. Again, you have the answer key to verify that you're getting the right answers. Circle the ones you're still having trouble with, and I'll try to help you on Thursday before the test.